Friction can increase with speed for several reasons, depending on the type of friction and the context. Here's a detailed explanation of why friction can increase with speed in various scenarios. 1. Air resistance drag. In the context of an object moving through a fluid like air or water, the frictional force known as drag increases with speed. This is because drag force depends on the speed of the object relative to the fluid. For most objects, drag force Fd can be approximated by the equation equals 1 to Fd equals to 1 to Cta, where is the fluid density, v is the speed of the object, Cd is the drag coefficient, is the cross-sectional area of the object. As Pv increases, the drag force Fd increases with the square of the speed. This is a significant factor in activities like cycling, driving, and aviation, where higher speeds result in much greater air resistance. 2. Kinetic friction. Dynamic friction. For surfaces in contact and sliding past each other, kinetic friction is generally considered to be independent of speed for most common materials and moderate speeds. The kinetic friction force Fk is given by equals Fk equals Kn, where K is the coefficient of kinetic friction and is the normal force. However, at very high speeds or in specific conditions like certain lubricated surfaces or soft materials, the kinetic friction can increase with speed due to factors like temperature effects. Higher speeds can increase the temperature at the contact surfaces, changing the material properties and increasing friction, deformation and vibration. At higher speeds, surfaces may deform more or experience vibrations that can increase the effective friction. 3. Rolling friction. For rolling objects like wheels or balls, rolling friction can also depend on speed, though this relationship is complex and varies with the materials and specific conditions. At higher speeds, rolling resistance can increase due to deformation of the rolling object. Increased speed can lead to greater deformation of the rolling object and the surface it rolls on, increasing the rolling resistance. Hysteresis losses. The energy lost in deforming and then returning to the original shape, hysteresis, can be higher at greater speeds. 4. Fluid friction. In lubricated contacts and mechanical systems with lubrication, fluid friction can depend on the speed of movement. As speed increases, viscous drag. The viscous drag between the moving surfaces and the lubricant increases. The viscous friction force Fv is proportional to the speed v. Fdv. Where is the dynamic viscosity of the lubricant?